So today we're going to go ahead and move on with 11.1. Talking about, this chapter talks about sequences and series. And this lesson is going to be a lot of review of what you've done in geometry already. Bree? We're going to talk about identifying mathematical patterns and then using formulas to find the nth term. Today we're going to talk about explicit formulas and recursive formulas. Okay? So first of all, what's a sequence?
I don't know, you tell me.
Yeah. Hold on.
So a sequence is an ordered list of numbers the book, I'm not sure they identify these. I think they think you already know them. But I'm going to identify whoops there. I forgot something. Yeah, I don't like that. An arithmetic sequence has a common difference from one term to the next, where a geometric sequence has a common ratio. What that means is, in an arithmetic sequence, we're going to add or subtract the same number each time to get the next term. Where in the geometric, we're going to multiply or divide each time to get the next term. Dividing, same as multiplying by the reciprocal. Subtracting was the same as adding the opposite. Okay? So those would be the difference between the two. And you've dealt with both of these before in geometry and probably in Algebra 1 some. But today we're going to talk about them even more. In this chapter we're going to get very familiar with them. Okay? We have two kinds of formulas. The first one is called recursive. Writing in cursive, and then there's writing recursive. That's kind of like doing it again, right? No, not really. Sorry, that's bad. All right. So a recursive formula looks a lot like this. They tell us what the first term is. And so if my first term is 7, then they say that it's T1 is equal to 7.
Oh, it's 1.
And then they tell us how to get T sub n. Well, it's going to be T sub n minus 1 plus 3. Okay? And usually they have a little disclaimer here like, for all n greater than 0. Greater than 0. Oh, and they say integers, for all integers, sorry. Kind of run out of room there. For all integers n greater than 0. All right? Now, what does n minus 1 mean?
We don't know. Hold on, let me find out.
If I want the nth term, then what would be the n minus 1 term? Yes, Kendra? Yeah, the term before, right? So if I want the 8th term, then n minus 1 would be the seventh term. Right? Recursive formula is very simple. What's the second term going to be in this? 10. What's the third term going to be in this? 13. What's the fourth term in this? 16. It can't get any easier than that, can it? All you have to do is what? Add 3 each time. Here's the downside. What if I want the 1000th term?
You gotta go all the way to
Yeah, what do I need to find the 1000th term?
You have 999.
I need the 999th term, right? And to get that one, I would have needed the 998th term. So in other words, like somebody already said, we have to find all of these all the way up to 1000. Now that's not very helpful, is it? This formula is not very helpful in that method. Okay?
Could you just multiply 3 by 1000 and then
Well, now you're talking about a different formula.
Oh,
Okay? Recursive, you have to add the previous term each time. The second formula is called explicit. And an explicit formula allows us to find the value of a specific term. Okay? It allows us to find the value of a specific term. Now, this recursive formula I wrote here, this is for an arithmetic sequence, isn't it? Because I added each time to get it. If it was a geometric sequence and I was multiplying a common ratio, then instead of t sub n minus 1 plus 3, it might be t sub n minus 1 times 7, or divide 2, or whatever. Okay? Explicit, we would have to figure out what to do. Yeah?
Can you have like square roots and squares and like and arithmetic sequences?
Can I find what?
Can you like, I know you have multiplication and division, but can you have like square roots and squares?
Yeah. In your sequences?
Yeah.
Yes. Yes, you can. These are not limited just to arithmetic and geometric, but for the most part, what we're going to do is going to be those two types of sequences. Okay? We certainly have the ability. The sequence is more general than just to those two specific situations.
Yeah.
Okay? And that's why it's difficult for me to write a formula here. Let's together, let's try to discover what our formula would be for this one we had up here. Let me rewrite it. 7, 10, 13, 16, and so on. Okay, that's a 6. All right? If we want to write an explicit formula for that, what are we adding each time? 3. And so what I do is I say, well, what's the common difference? In this case, it's 3. So it's going to be 3x. Or let's go t. 3t. Okay? But 3 times 1 is what?
1.
3. And I need my first term to be 7. So what do I need to do to 3 to get to 7?
Plus 4.
Add 4. So let's check it out. What if t is 2? What if I'm on term 2?
Well, then you gotta add.
Then 3 times 2 is 6 plus 4 is 10. Did it work? What if t is 3, the third term? So 3 times 3 plus 4. 9 plus 4 is 13. So there we go. We found our formula, didn't we? So our explicit formula would say t sub n is equal to 3t plus 4. Oh. Actually, they would use an and. Sorry. No. The question was, would it always be 4? And absolutely not. If I had one, if my sequence was 1, 4, 7, 10, okay? I'm still on the same sequence, aren't I? Except my first term is no longer 7. But I'm still adding 3, so I go 3n. But what's 3 times n? 3 times 1 for the first term. 3. But I need to get to 1. So what do I do to 3 to get to 1? Minus 2, right? So if my sequence was 1, 4, 7, 10, 13, 16, then my we'll say t sub n is going to equal 3n minus 2. And it's kind of important if I use a subscript of n, I use a variable of n, because it means the same thing. If I want the 4th term, then I'm going to put 4n for n. Okay, if I want the 1000th term like before, what is the 1000th term now?
Plug in
Yeah?
1000.
Join me. What's the 1000th term now of this original sequence we looked at?
Oh, the original?
Isn't it 3 times 1,000 plus 4? So do you think that's
4. I was looking at the other one.
So it's, Matt, it's not that. We just found the formula, right? The explicit formula for that situation. And so we said it's 3 times the number of the term we want plus 4. And 3 times 1,000 is 3,000 plus 4 is 3,004. So the 1,000th term would be 3,004. Okay? So that's part of your assignment. I want you to do the recursive and make sure that that's right. Just kidding.
I would say.
No, don't really do that. Okay? Although I remember when I was quite young, we used to just fill a page counting.
You were young.
Yeah. You know, before dirt was invented, and
There was a minute.
yeah, and there was no such thing as fire. I mean, how they ever come up with that spark, I
Did you
still
wear
don't know.
those skirts and stuff and carry around like bum?
We didn't wear skirts. We just had
They just ran around
we
me.
just had a few leaves scattered around. All right.
Bad sight.
Any questions on that? Okay, I'm gonna pause for just. Okay, here we go. On example number 19.
Wow.
They want us to write an explicit formula. Girls? They want us to write an explicit formula.
Or did you just add one to the
So I'm going to say t sub n. Okay? And n is going to represent the number of the term I'm on. What's happening in this sequence?
It's going up by
What is?
1.
The bottom number is increasing by 1 each time.
They're getting smaller.
What's happening on the top?
It's the same.
Okay, so how might I start my sequence?
1
1?
over
1 over 1?
1. That's just 1. 1 over n plus 1.
1 over n?
Plus
1 over n plus 1?
Yeah. Yeah, that sounds right.
Okay, well, let's look at this. If we just said 1 over n, then the first term would be 1 over 1,
It's 2.
which is 1, and that was not the first term, was
So
it?
it's plus
The first term was 1 over 2, and so, remember, n stands for the number of term we're on. We have to get that to a 2. So 1 plus 1 is 2. If I'm on the second term, then I get 1 over 2 plus 1, which is,
3.
okay. So what's the value of the 100th term going to be? 1 over 101. Okay? So this is going to be my explicit formula. Okay? All right. So today's assignment.